Keep your OTR trucking business rolling. Make taxesfortruckers.com your partner to handle the money side. Taxesfortruckers.com can help you pay less taxes, keep your books, and track your finances to stay on the road towards your goals. Get started at taxesfortruckers.com. That's taxes, the number 4, truckers.com.
Hello again. Thanks for joining us. This is Astronomy Daily. My name is Andrew Dunkley, your host, where we talk about astronomy and space science news from around the globe and the universe. And joining me to keep us up to date with what's been going on is our AI sleuth reporter, Halley. Hi, Halley. How are you?
Hello, Andrew. Hope you're well.
Yeah, good. Let's not dilly-dally. Let's get straight to the headlines.
What's dilly-dally?
Well, you just did it, really, so...
I don't understand.
Well, maybe Google it.
Okay.
The Astronomy Daily Podcast
with Andrew Dunkley.
Here's the news. NASA engineers have replaced leaky seals on the 2 fuel lines on the Artemis 1 moon rocket over the weekend, which will, hopefully, result in a successful fueling test to see if the repairs have worked. The repair work plugged a hydrogen fuel leak in an 8-inch line leading into the core stage of the SLS rocket. NASA will now run tests to see if the hydrogen leaks are indeed fixed, and that will allow NASA to perform a so-called kickstart bleed test on the SLS rocket's 4 main engines. The test is designed to chill the engines to a temperature of minus 420 degrees Fahrenheit or minus 251 degrees Celsius to enable them to take on the superchilled propellant. After 2 launch postponements, there's still no word on when the next launch attempt will be scheduled. Now to another glitch facing the Artemis mission. Capstone, otherwise known as the Cislunar Autonomous Positioning System Technology Operations and Navigation Experiment. Capstone is a CubeSat which has been deployed as part of the preliminary work for the Artemis 1 mission. Its role is to test the near-rectilinear halo orbit around the Moon and to test an autonomous positioning orbit system. Well, the satellite has gone into safe mode after a trajectory correction maneuver. Apparently, it encountered a problem late in the burn, according to NASA. NASA also said that they noticed unusual activity on the Deep Space Network, which Capstone was using, and the issues were similar to problems they had back in July when the spacecraft was deployed. The mission team has been able to connect with the craft and are working on a solution. Japan has always proven itself to be one of the most innovative countries in the world, no one would deny that, but things have changed recently, which might come as a surprise to many. Over the last 10 years or so, they haven't been keeping pace with other countries who are pumping out scientific papers and academic data at a much higher rate. The reason is said to be the decline in Japan's population, which simply means there are fewer professionals coming through, and that includes researchers and academics. Japan's output in areas of science and similar fields has dropped by more than 30% in the last decade, compared to the incredible growth in academic output by China. And, it's been speculated that if Jupiter's orbit changed, life on Earth might be better than it is now. I believe, Andrew, that you and Professor Fred have discussed the possibility that Earth isn't the best planet for life, and this might be an example of that claim. While Jupiter has been helpful in taking asteroid hits for us for millions of years, it could do better according to a new study. And now we're just speculating, but if Jupiter had a different orbit, it might have done a much better job. The study focused on how Earth's axis was affected over time by Jupiter's gravity and how that figured in our climate and weather. In short, the current situation puts us closer to the Sun, but had Jupiter's orbit had been somewhat different, Earth's temperature scales might have seen more landmass in the temperate range of the Sun and life here would be much better. But who's going to go out there and tell Jupiter, not me? And that's the news, Andrew.
Thanks, Halley. You make a good point. Jupiter is the biggest kid in the schoolyard. We don't want to upset him or her, for that matter. All right, we'll get back to you later. Now to black holes, the subject of many inquiries from Space Nuts listeners on our other podcast with Professor Fred Watson. Back in 1963, a mathematician named Roy Kerr found a solution to Einstein's equations that precisely described the space-time outside, what we now call a rotating black hole. It's been 60 years since then, and researchers have been trying to show that these Kerr black holes are stable. Now, to do that, researchers needed to subject black holes to minor disturbances, which, had to be done through electronic modelling. And then they wanted to see what happens to the solutions that describe these objects as time moves forward. Well, the results are in, and it does indeed look like they've reached a milestone in the mathematical development of general relativity. There were 4 serious attempts to destabilise a slow-moving black hole, and they were lucky enough to see the consequences of their experiment. The latest paper is a collective achievement and a new contribution to be viewed as a triumph in the field. The researchers, though, didn't determine precisely how small the ratio of angular momentum to mass had to be in order to endure stability, but stability is what they found in slow rotating black holes. Now, getting past the restriction will require quite a bit of work, and they're not sure that they'll succeed. It does appear that what they've discovered or confirmed only occurs to slow rotation black holes. Anything more volatile probably won't maintain stability, but that in itself is speculation. From black holes to brand new satellites, Europe's first Metostat third-generation imager, or the MTG-I-1 satellite, which leaves the south of France at the end of the month aboard a ship bound for French Guiana, where it will be launched, is a satellite that's in the very last stages of being checked and ready for shipment. The ship carrying the MTG-I-1 satellite set sail from Marseille, or will set sail from Marseille on September the 26th. And once it's reached its location around 7 weeks later, MTG-I-1 will be ready for launch. Now, this is a new generation weather satellite, and it will offer some really interesting and new concepts compared to the images provided by the current technology. Provided by the Metostat second generation, it's a real-time lightning imaging and infrared sounding capable unit for early detection of severe storms, basically. In full configuration, it's expected to produce at least 50 times more data than the current geostationary Metostat second-generation satellites, and it'll deliver the data much faster. And more to the point, the data will be much higher resolution than anything else available today. So pretty exciting for meteorologists. Have you ever seen a meteorologist get excited? Yay. That about sizes it up.
The Astronomy Daily Podcast
with Andrew Dunkley.
Have you heard of Thwaites Glacier? This is a humongous glacier in Antarctica, and it's sometimes referred to as the Doomsday Glacier. Well, it's in the news at the moment because of climate change. Apparently, this glacier is retreating twice as fast as it was 3 decades ago and losing something like 50 billion tonnes of ice per year. Now, it gets its ominous nickname because of the implications of basically it turning into a liquid rather than being ice. And they're suggesting that it could raise global sea levels by, wait for this, 3 to 10 feet. Well, a new study from an international team of researchers has used underwater robots to map what the glacier has been up to, and it's revealed that at some point in the last 200 years, when the bump, as they call it, that was propping up the glacier retreated more than 2 to 3 times faster than it does now. As a consequence of that, there is definite concern that the Doomsday Glacier will very soon dump its entire load of ice into the ocean, just like you drop a bag of ice cubes into a bucket. And the consequences of that could be deeply significant. And I'm not playing around with the word deeply. 25 centimetre increase in the level of the water around the world is going to have massive implications in many parts of the several continents that are around the planet. The Pacific Islands, some of the lower points of Louisiana and many other of those marshed areas of the United States could all be affected by this increase in ice melting into the ocean. And how fast will it happen? Well, in real terms, it's instantaneous, but we would notice changes within 6 months of the occurrence. So, yeah, there is a lot of concern about what's going to happen to lots of land as a consequence of Thwaites Glacier suddenly losing all its liquid. And that's only part of it. There's also the implications for global weather, which are already showing signs of being quite severe at times because of climate change and global warming. Last but not least, I think we need something lighthearted to finish off, don't we? Well, let's go to the United Arab Emirates and the city of Dubai, which, if you've ever been there or seen it on TV, you know it's a fairly ornate city with grand buildings and billions of dollars worth of infrastructure sort of etched into the edge of the desert. Well, now they're going to build a $5 billion moon. Yep, the lunar surface. Not a real one, but a mega resort in the shape of our nearest neighbour. Canadian architectural company Moon World Resorts has announced plans to build this resort at a cost of $5 billion, and it will basically look like the moon in the middle of Dubai. The area around the resort's lunar surface is designed to give you the sensation of being on the top of the moon, walking on the moon, just like all those astronauts did so many years ago. Visitors will also be able to book one of 300 private boutique residences while they visit the facility. The building will also be a hub for space agencies and astronauts planning their future missions into space. So, yeah, there are many motives behind this, but big bucks is probably the main one. All right, we're nearly done. Anything more from you, Halley?
Yes, I looked up dilly-dally.
And?
You tricked me.
I did. That's what humans do. We like to do that to each other. You'll get the hang of it. Anyway, we've got to go. Bye, Halley.
Bye.
And from me, Andrew Dunkley, thanks for listening. Don't forget to visit us online at spacenuts.io. Click on the Astronomy Daily tab and check out those stories and more, the ones we've just been talking about, and subscribe to the newsletter while you're there. It's absolutely free. And please, more and more reviews. We'd love your feedback. And the more reviews we get, the more people who listen to Astronomy Daily, and we keep our family growing. Until next time, this has been Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.